So my name is Kyle Roach. I'm the general manager of the AWS IoT project. I'm excited to be here today, talk about Internet of Things at 6:30 in the morning Seattle time. So hopefully you guys are you with me on that one? So Internet of Things, let me see. There we go. So it is plural. I want to mention that it's plural for two different reasons. One, if you look at kind of what's happening on the analyst side, the marketing side, the hype side of IoT, we hear a lot about this 20 billion, 200 billion, whatever devices that are getting connected over the next 5-10 years. And on the other side, really, if you look at kind of the solutions that are being built, what we see coming out of projects like Kickstarter, new sort of incubated IoT solutions, we're really still seeing a single purpose application, focused around connecting that one particular thing to the internet. And I think this is actually expected at this stage. If you look at kind of where Gartner says we are in the hype cycle, we're right at the top, right? Which means what's next is called the trough of disillusionment. It's sort of a really exciting term there. Trough of disillusionment is really when all of these hyped up things that are creating the marketing buzz around IoT start to dissipate and the real enterprise use cases start to surface. So we'll really start to see what this is really about the next couple years. Keep in mind, I think as you're searching for IoT platforms and IoT partners, that plural piece is a really big part of kind of what you're going to need on the other end. You really don't know how big that single-purpose app will become when it is connected to the internet later on. So looking at kind of our business internally and how we focus on the Internet of Things, I think if you take these robotics, we have Amazon Robotics has hundreds of thousands of these in our fulfillment centers around the world. If we were to take this and build a single-purpose robotic app, that would make our fulfillment sort of business a little bit more complicated than it already is. So these are already working in concert with the e-commerce side, with other parts of our business to deliver packages to customers in a reliable, quick, and secure manner. So in some cases, actually, we can get a package off the shelf using the robotics on a truck and to a customer within an hour in metropolitan cities. So there's a lot of coordinated efforts, not around this one particular machine, but the set of machines working together to serve that particular purpose. So these things are not static assets. Once they're connected to the internet, they can start to grow in functionality, learn new behaviors, and bring new value to customers. So take Tesla, for example. Tesla, the slides are jumping there. There we go, sorry. Tesla released an over-the-air update a couple months back to introduce an autopilot mode to the car, so it can drive unassisted from the driver for a short period of time. After that, they introduced another feature called Summons. Summons when you can actually tell the car to open the garage, leave the driveway, come out and wait for you with nobody in the driver's seat. So pretty amazing features. These are happening to the assets when they're already in the field. The mechanics and the electronics are not changing at all, but the software is driving new behavior. Really starting to see kind of the value of IoT and change over time. I have the Summon feature in my car, and I actually, I have 5 little kids. When I come out in the morning, I pretend I have the force, like I can open the door and like pull the car, and the little kids kind of get a kick out of that. So back to kind of the point. We have a bunch of logistic vehicles as well in the field, so I think we can kind of relate to moving pieces around. We don't expect an autonomous driving update on any of these anytime soon. But they are being managed in a similar way. We need to look at location, maintenance windows, the wear and tear of different parts of the vehicles. And for us, the purpose, delivering a package to a customer from an order, doesn't necessarily mean that all the different things that operate in that manner can be measured in the same way. So look at other ways that we deliver packages. We have Amazon lockers in metropolitan areas. These are physical assets in certain locations. You come up, you log in. It opens up your packages there that you ordered. These are ready for pickup. So both of these things are serving the same purpose, completely measured in different ways in respect to IoT. Obviously, we also have the drones project, which is creating a lot of buzz too. But this is another mechanism to be connected to deliver a package, same purpose as the other previous ones, but needs to be measured completely differently. So now, in the same respect, the customer that we're serving, sort of the end goal of these IoT projects, has multiple identities when it comes to these connected devices. So just keeping on this sort of delivery theme for another minute or two, Prime Now, our 1-hour delivery service in different metropolitan areas, we use contract drivers. So now you look at, some of these people are employed by us, some are employed by delivery companies, DHL, USPS, UPS, FedEx, whatever. We have contract drivers as well. So the security profile, the access to the machine and how things are working are all different depending on the different party there. All serving that same sort of customer purpose, though. In Europe, we're actually opening the trunk of Audis to deliver packages there in partnership with DHL. So in a similar way, now the same exact business purpose, we're now introducing partners through Audi, another manufacturer, through DHL, another delivery mechanism. So we own some of the trucks, we're leasing some of the trucks. Some people are employed, some are contracted, some are partners. Lots of different profiles around the same purpose. And there's kind of the challenge of the multiple dimensions that we see in IoT today. So lastly, today I'm going to talk mostly about AWS IoT and our, sorry, the slides are jumping on me, and our focus on the enterprise. But we see the home in the same way. I think we're solving similar problems: security, privacy, scalability, mostly usability in the home, and we have a family of devices around that too. And some of these will actually help enable, if you are working in the home, enable sort of taking advantage of that broader collection of devices and the aggregate information available. So one of the interesting things about Echo, you're actually adding another device into your environment that's helping you remove the controls from physical products that are already there. So we're getting more of a harmony around all these different connected products, but we have less of a need for remotes and controls and things like that. And we're using natural voice interaction to start to bring value out of the connected products. So with all that in mind, we built AWS IoT. We released this last year at reInvent. It went GA in December. So at the center of the product, this is what we're going to focus on today, the kind of architecture of the product and how it works. And I'm going to introduce a bunch of new features that we've released in the last month. So at the center of AWS IoT is the device gateway. The device gateway is really a message broker. It's responsible for routing messages between the different components, picking them up from devices, and getting them to the end business application. We introduced a new concept called the device shadow last year. The device shadow is basically a logical representation of the physical device. It creates an abstraction layer so that application developers can interact safely with the physical product over a REST API instead of connecting to the device in the way it does connect. Maybe I should put this down. I'm still doing it. I don't know if that's me, guys, but the slides are jumping. Yeah, see them? Okay. So on the device side, if you look kind of at the wind turbine here connecting, we introduced a bunch of new security patterns to get physical products connected and secured to the internet in a different way than we're used to. AWS is traditionally focused on people-based systems with their IAM roles and policies and accounts like that. So devices need to be secured and managed in a different way. We have the device registry, which is a different component. We'll start to see that as sort of the landing pad for our device management features over time. Right now, this is being used as the metadata store to describe the capabilities of the device and some of the information around the business system. So the rules engine up in the top left, we're going to talk a lot about that today. The rules engine sort of being shown in that upper plane there. It listens to all the different messages that are going over the wire, inspects them, can react, pull information in context, filter out the noise, and basically behave on behalf of your business logic. There we go. All right, so I'm going to sprinkle a couple of these things in through the talk. First, we launched a new region last week. So we are now generally available in the EU Frankfurt region. So one of the strong things there, obviously, our automotive business, and as well as the privacy laws. So there's a lot of customers asking for access for the IoT platforms through the EU Frankfurt region. And this is a big priority for us this year, regional expansion. So we'll see these announcements come at a kind of a more increasingly fast basis throughout the rest of the year. So let's first talk about basically routing noise. And this is sort of the easiest thing, the first step that we see when we start connecting devices. So the device connects. Typically these systems, if the device already existed, it was running in some sort of siloed environment. It was on the LAN or whatever. It has a little control tower in the oil and gas field out in the wherever it was deployed. All these messages are being routed, and it's kind of safe to send that amount of noise. When you start connecting things to the internet, this gets a little bit less usable. So this device gateway, the centerpiece for basically the architecture, it's based on a topic-based architecture. Really, it's a hierarchical organization of how you're going to classify your messages. So topics become very important. So if you look at an IoT system that's sort of device to device or an application to device, you get this kind of one-to-one relationship between business logic. Now, devices can talk on a topic. Multiple devices can share the same topic space. Applications can join in on those topics. So using a topic instead of that sort of singular notion of a device channel gives us a little bit more flexibility to look over the aggregate of all the different messages. Cool. So talk a little bit about sort of the publish-subscribe pattern that's underneath this topic-based architecture. And one of the things we heard from customers right away, and this is one of our design tenets for AWS IoT in general, is that if you're putting this asset in the field for multiple amount of years, you don't want AWS code on the device, or you don't want to be forced to put AWS code on the actual device. So everything we're building with AWS IoT is based on open standards. We use MQTT, HTTP. We added WebSocket support earlier this year. And you can connect with any open source MQTT, WebSocket, or HTTP client that supports TLS Mutual authentication. So we're secure by default. TLS Mutual auth is actually a pretty high bar for connected devices. So if you're in the hobby class, like the Arduino Uno class, it's going to be a little bit outside of what that device is capable of handling. But if you're at the Arduino Une or anything higher than that, in which most people in the enterprise are these days anyway, TLS Mutual auth is actually acceptable. Long-lived connections, this is kind of a big shift for us too. SQS, another AWS product, has supported long polling for quite a while. We've added these persistent connections. Custom keep-alives are part of AWS IoT as well, so you can really use this to keep a channel open to the device with a minimal amount of ping traffic, very light over the wire. And then I can instruct it, do command and control events, even traverse a firewall to wake a device or give it instructions on what it should be doing next. So what exactly are we passing around? If we kind of dissect these sensor messages that are going back and forth from devices to applications, we see a couple key parts that we're able to react to. So first, by the way it's connecting, by the port it's using, the certificate, I can see who's sending this message and over what protocol. So that's pretty easy. Now, inside the message itself, we have two things that we can react to. We have basically the topic, which I talked about earlier. One of the key things here to note is that as we add these other different protocols, MQTT and WebSockets, we'll take that topic-based paradigm and we'll mirror them across these protocols. So I can do things like have a device that publishes on an MQTT topic space and have a live web application that listens and visualizes over an MQTT or a WebSocket channel. So these things will go back and forth and interop natively. So that topic is there. I can set rules based on the topic. I can set rules based on topic filters, on wildcards, on search patterns, things like that. Inside the payloads, we support JSON today. So we are introducing a bunch of new features very soon to handle non-JSON-based payloads. And we can talk about that after the session if you're interested, if you have questions on how that's going to get implemented. JSON-based payloads are kind of the core of all the messages. And if you do send JSON, the rules engine can start to mine the data on the fly. And again, all these things are happening at the topic level, not this particular message or device level. So now with all this noise going around, kind of how do I start to mine the data that's underneath and really find the signals? There we go. So, I'm using the rules engine to really start to add value to my different devices or to the different messages. So like I might have a lot of noise going over the wire. I want to filter for certain criteria. Or I want to take topics or messages from a particular topic and move it to another topic. So we see this a lot with alarm-based topics. I might have a command center or NOC somewhere in the field that's only listening to things of a higher order. So I can use the rules engine to filter out the noise, move everything to an alarm channel, and have that operator, that dashboard, start to sit on top of an alarm topic. And I don't even have the thing now, so that was definitely... sorry. Cool. All right. So yeah, I can move messages to others. It really wants me to show you this slide instead. I'll hold it again. So I can move messages to other systems. We're working pretty hard with SAP in partnership with partners like Splunk, with Salesforce.com, on how do I route messages from the IoT system back to the business application, whether or not that's actually in the cloud, which is a very interesting sort of play for us, and a little bit different than what we've seen in the past. So what about transformations? As folks start getting into data mining, analytics, prediction, machine learning, the format of the message becomes very important. You can use the rules engine for transformations of the sensor message on the wire. So we will deliver it in its new format to the receiver. And I'll show you how some of that will work as well. Predict and machine learning. Okay, now you guys are just messing with me. I got one going back and forth and the other one's out. So predict and machine learning, these are kind of hot topics these days, right? And we're going to talk a little bit about how the rules engine is going to feed that using Amazon machine learning as well. But today, most of our customers, a lot of us are still in React mode. So what we want to do is we want to find the signal that's in all of these messages and send it to something like SNS, so I can page an operator, I can send out an email, or I can kick off a trouble ticket, something like that. Okay, so let's talk a little bit about the rules engine. So the rules engine sits on top of that message bus, like I said. It's going to listen to every message that comes over the wire. This is basically the largest subscriber in your system. You tell it basically which topics and which patterns you want it to listen to, and then it can start to look for patterns and then react. So kind of how do these things work? There's two different sides. Sorry, that one was actually me. I'll get a hang of this right around like minute 40, and then you guys can ask questions. So the rules engine has two different ways to interact basically with the data in other parts of AWS. Now, first we have something called a function. So a function pulls data in context of the rule. So I might use this to pull something out of, it'd be like ideal to pull it out of a Dynamo database or pull it out of a ThinkShadow or something like that. I use the function to pull the data in context, and I look at other parts of the sensor message, like is temperature greater than 70, and this function's returning the value true, and then I can start to do things. The other end of the rule is really the action. So if I do find this pattern, if I do find that this is true, what do I do with it? So we have a whole set of integrations with other AWS services. We added CloudWatch alarms and events last week, and we're adding more all the time. I'm just going to run with it as it changes now. So if you look at kind of the syntax that we have underneath the rules engine, we paired it up with SQL streaming syntax. So if you've ever seen that, it's a very familiar sort of pattern. Kinesis Analytics, which is launching later this year, is adopting the same pattern. So we wanted really to have the developer experience start to be consistent. So we have a basic select statement. So what we're doing is we're selecting data out of the sensor message from a topic. So you can say that this topic is sort of like a database table scan, and then we can add a filter to that. So now, like I said before, inside that select clause, we support a bunch of different functions. I think we're up to almost 60 of these functions now, ranging from string manipulation, regex support, mathematical operations. You can do things like look at two different readings, try to average them out over time. There's a bunch of context-based helper functions, like pull the second element out of my topic, or look for my device client ID from the MQTT connection. You can do timestamping, crypto support, generate random numbers or UUIDs. So basically, it's a mini little scripting language that can prep the data for wherever it's headed after it comes over AWS IoT. Another key thing here that I think we're not doing a great job of educating customers around is that each particular rule can execute an array of actions simultaneously. So we see a lot of customers, they come to us with 100, 200 rules on the same topic. And you can really kind of start to bundle these together and get a little bit more value out of strong topic design, strong rule design. So keep that in mind. You can execute multiple actions at the same time. So you could say, I'm going to store all my sensor data in DynamoDB. I'm going to also send it to Elasticsearch, and I'm going to fire this Lambda function every time a filter whatever, meets some certain criteria. And you can do all that with one particular rule. One of the newer features coming up this week, we added versioning to the rules engine. So this came out of customer requests from our kind of more stringent manufacturing-based customers, so in automotive and medical, places where the design cycle and the hardware cycle have to be very sort of fortified all the way through. So they wanted to say, I want the rules engine locked. I don't want any changes to it over time. So we basically added another field. You can put this inside your rule syntax. And you can call out basically the original version. You can always sit on top of our beta. So if you're into kind of programming excitement, you can do that. Or the last long-term supported version is always there as well. So those will change over time. We will add new features. So there's a possibility of breaking changes there. So you can always use a specific version if you're interested in that and you want to tie that to the design cycle. Another request that came out of customers, this is also new this week. We have folks that are sending very large, complex JSON payloads coming out of machines with 300, 400 sensors. They're taking an aggregate read, sending that entire thing as one sort of batched message. So we're adding more functionality to mine that data in real time. So now you can go through one of these sensor messages, use this new get function to climb through the collections. I can pull objects out of an indexed collection. I can get a particular position in an array, or we have other customers too. The sensor one is actually very interesting. It looks rather boring, pull a character out of a string. But if you look at some of these older devices that are sending things over cellular, they're using basically a binary string that means 8 or 10 different readings in a row. So if you do get that into JSON format as a string, you can really use Lambda and some of these other features to go back and add that business logic to that older legacy proprietary protocol. And this sort of function helps you with that too. So I can grab what's the position in byte 4 out of this string that's coming over the wire. So in the spirit of talking about new stuff some more, rules, like I've been talking about so far, are based on topics, right? So you get kind of a minor sort of aggregate view of a portion of their connected devices. So I can sit and listen to all the topics in, or all the devices in my North America, whatever topic. Now, we added, based on customer feedback, we saw customers that were coming to us with like, hey, I have to daisy chain a bunch of actions together. So I have to take all of my messages, and then I have to send them to Kinesis. And I have to get another Kinesis rule, and I got to fire a Lambda function. I get Lambda, and I'm basically just putting it all on Elasticsearch anyway, because I want to do a full text search across all of my sensor packages. So we introduced a native function in the rules engine for Elasticsearch as well. So you can kind of skip all the different middle operations with a couple lines of code. You put that in the rules engine. You say anything that meets this particular pattern, just send it right to Elasticsearch. That gives you basically that full text search capabilities across all of the sensor messages at once. So now instead of doing things like look for this one condition that came in my sensor package, I can start to full text search, show me average speed in this region over the last 5 minutes, and kind of get a better feel for what's actually happening. A couple other things I'll talk about and why Elasticsearch is becoming more and more important for IoT. So Vadim, who's sitting here in the front row, he's talking after the keynote. He's basically got the opposite session of me, so I have all the PowerPoint, he has all the cool demos. God, come on. Okay, the sound effects, that's what does it. So we're going to show a little bit of what's called Cabana. Cabana is a visualization framework on top of Elasticsearch. So Amazon Elasticsearch service ships with Cabana. With a couple clicks, you can get this set up. With one rule, you get everything funneled into Elasticsearch. You can start doing visualizations in a couple minutes after your messages are flowing. So these dashboards will refresh in, I think the lowest is 5-second increments. They all coordinate together, so if you did filter that map, all the graphs that are around it would filter in context as well. So a very powerful tool for really quick visualizations, and these can be exported to your customers. They can be put into iframes, imported. So you can really get a lot of stuff done in a short amount of time using this new rule. Now, I think Elasticsearch is important, obviously for full text search, but also for something that we're calling lifecycle events. So we'll see more of these patterns start to emerge, and these aren't really features that we'd make a big splash about. We think they're very convenient and they're usable for customers, so we'll continue to message them through blogs and forum posts and things like that. But if you look at Elasticsearch and how I'm mining data for context across my entire fleet, lifecycle events become very important. So a lifecycle event, the first two that we released are basically the on-connect and the on-disconnect. So every time a device connects to AWS IoT now, it sends out a little message, here's my on-connect message, right? So I can take rules and I can attach it to that topic. So I can start to do things like build presence around my devices or do onboarding or provisioning or automatic rerouting of policies and permissions based on that connection message. I get the same when the device disconnects. So now overall, if you put this in Elasticsearch, you can start coordinating things like, not that. You can start coordinating things like when this device is connected, how close is this to the incident that I'm managing, what are my trends, what part of the day are these devices connecting more regularly, and start managing basically the life cycle of all the devices in aggregate. So one of the other demos that we're going to do after the keynote is around another new feature of the rules engine. What we did is we had one of our data scientists on Vadim's team come up with basically a theoretical machine that has really just 7 working parts. So it's kind of a simple machine, but we put some complex relationships in place. So if you pick any 2 of the different parts that make up this machine, in our case it's just a wind turbine, they have a relationship together. So there's dependencies between the 2 parts. Now all these parts and all their dependencies together, they're all wearing over time as the cycles progress. So what we're doing is we're walking through using a simulator, kind of a complex relationship of machinery, looking for wear and tear in the different parts, and then we're going to try to predict the maintenance window. So this would be very difficult to do with the rules today. So we have customers that are taking this type of data, sending it to S3, running Amazon machine learning predictions, and then using Lambda functions and things like that to kind of mine and see if the data is ready. So we added a new feature to the rules engine this week or last week. We're calling the predict function. It's actually like machine learning _ predict, but the idea is that we can wrap all of that functionality the same way that we did for Elasticsearch and let you run predictions in context of the actual rule. So now I can say things like, if I see a reading of oil pressure greater than this for this amount of time, and my prediction is saying that my maintenance window is within the next 20 cycles, then I want to do something with the rule. So we're adding that live kind of prediction to the rule before any of these actions take place. So you can think of this logically sitting inside the rules engine. We're making an asynchronous call to Amazon machine learning. We wait for that response from what's called the real-time prediction endpoint, and then we inject that back into a second message on the same or another topic. So what Vadim's going to walk you through kind of in a more elegant fashion is basically the simulator generating some data. We're going to set up an AWS IoT rule. This will forward everything to S3. This is kind of where Amazon machine learning pulls its data to build the models. We'll use AML with the S3 data source. We'll start running predictions. This is one of the steps that we'll skip in the demo because the first run takes 20, 25 minutes. And then we're going to enable a real-time prediction endpoint. So a real-time prediction endpoint is basically a URL. It's a webhook that you can get in AML. And every time I call it, I send it basically all the context I have about my current state of that model, and it'll give me back the fields I'm asking for. So in our case, we'll be looking for the prescribed maintenance window, duration, how many more cycles do I have left on this part. So the rule is basically using the validated prediction feature, and then you can start to add other actions on top of that. So now I can say, if my prediction maintenance window is in the next 20 cycles, fire this Lambda function that calls Salesforce, opens a field ticket, on and on and on. So the actions sort of get strung on from there. Now, if you don't have a chance to make a Vadim session, we did just blog this a couple days ago. So there's a full walkthrough of creating the simulated data set, setting up the AML model and the prediction endpoint, and then running through this kind of on your own. So if you missed that URL, you can get it from me later today too. So I want to talk a little bit about device shadows. This is the feature that we introduced back in October when we released the product. The device shadow is basically in the application stack side of AWS IoT. So it's how application developers, whether that's on the Amazon Echo skills or mobile app or web app, how they're interacting with the physical product. Now, if you look at kind of a lot of what we're doing today, you can start to see how the shadows is becoming more and more important for enterprise use cases. That abstraction layer adds a lot of different value other than state management. We talk about this a lot as the shadow managing state on behalf of the physical device. So I can tell the shadow things like, hey, I want to turn the light on. The shadow tells the device says, yep, I did that, and then shadow tells the application developer. Simple use case, but there's a lot more complexity going on. So in that case that I just talked about, we're basically publishing state to AWS IoT. We're storing that for you. It's available through a REST API. Any of the applications can ask for the state at any time. We version that. We do conflict resolution. We'll manage the locks between state requests. The app can say, hey, look, I don't want the state to be off. I want it to be on. So go ahead and make a change. We tell the device on its behalf. So then we have this sort of pending state where the device says, hey, my reported state is this, but my desired state is something different. So we'll manage that diff for you as well. When the device does acknowledge and change its state, it tells us, and then we go ahead and tell the device or the application that's asking for it that everything's sort of resolved. So underneath, this is all basically living in a JSON doc. Now you can see the shadow in the console. So if you want to interact with this, non-programmatically, you can log into the console. You can edit the shadow and change some of these fields, and we'll send those requests on your behalf. I'm kind of showing a simple example here, but basically the reported state of the device is green. That's the last known state the device has told us about, and the delta is basically red. So there is a difference there, and we'll manage that until it resolves. I'll go back to the shadow here and there during the security session here, which we're going to start in a second. So just to talk about security, I wanted to kind of lay up, this is a AWS security slide, so this isn't one of our slides, but I think these operating principles that AWS in general is using is kind of what's guiding a lot of the way that we design the security around AWS IoT. So a couple key things, we talked earlier in the presentation about the different actors, the different users that are in an IoT system. So we believe that their different roles should be separated with respective policies. So you should get basically the policy of least privilege that lets you do your job function within context of the full environment. So security, we talk a lot about it. We illustrate about it as the device talking to the cloud, but it's a little bit more complex than that. We talked about the new schemes that AWS IoT introduced into the ecosystem specifically for devices, which mostly is around certificates. But I also want to mention kind of how you secure the rest of the assets in the system. So if our rules are kicking things off in your account context, like your Lambda functions, and we're accessing your Dynamo tables, and we're running machine learning predictions in your account, how do you protect that and know that the system's doing exactly what it's supposed to? So we're going to walk through that real quick too. So to start with, we'll talk about the device side. We launched with, like I said, TLS Mutual auth. Basically the steps here, we create a certificate request. We create a certificate from that, which is actually managed by the AWS IoT Certificate Authority. You can activate it, you can attach a policy, or you can create a policy and then attach it. And this basically gives the device, or whatever's using that certificate, permissions to different topics, to different resources in the system. Now, certificates can be shared among devices, so we have customers that use the same cert for their entire fleet, and they just switch the device ID. We'll let that go. You can also create a unique certificate for each device. We've had a lot of customers tell us that this isn't really good enough. I mean, they don't want, in the same respect that they don't want an AWS SDK on a device that's getting buried for 2 decades, or going on a car or something like that. They don't want us managing their certificates. So we released a new feature this week called Bring Your Own Certificate. So this is super important for medical customers, automotive customers, any of you guys that are in kind of the high-end volumes of manufacturing. There's a lot of different reasons you might want to use your own certificate and not use one by us. I mean, you have maybe an existing infrastructure. Maybe you're using an offshore HSM where there's no internet access when the machines are actually coming off the line. Or, most often it's something to do with sort of certification or maintenance, or the certificates are already out there. So if you look at this case in particular, that's just one little bullet point on a slide, but if I have a fleet of devices with its own certificate that supports an open protocol like MQTT, HTTP, or WebSockets, you can move that in its current state to AWS with no code from us and no additional code on the device. So that's a pretty powerful sort of set of features, and I think it's really showing that we're focused pretty heavily on keeping this an open and secure front door, with no lock-in in respect to the machine. So you'll see this surface not as a new product. It'll be 8 new API calls within the CLI and available in the console as well, so you guys can play with that today if you want. So a couple examples. Once we have these certificates, we need to attach policies to them that give them permission. So again, with the sort of idea of least privilege, you can allow or deny based on certain topic spaces. In these topic clauses, I can do things like asterisks. So I can say I want to deny this entire topic tree, but I want to allow this, one particular topic somewhere else. And then I can use different sort of actions. So the 3 parts that make up this policy, this effect, allow, deny, the action, and then the resource are kind of how these things behave. Now, I talked a little bit about the shadows, and what we're starting to see and we're starting to hear from customers is that these policies, I can use this now to completely separate my security paradigm from the physical device to the application or the end user. So I can do things like set up policies for update, get, and delete on ThingShadow, but have no access to the physical hardware whatsoever. So now every time I make a connection request or a change of state request to a physical device, I can, I'll get a message over MQTT that says a state request was changed. I can fire a rule on that. I can add extra logic on top of it. but there's basically a whole area of extra protection that you can introduce your own custom code and your own business logic around protecting the physical hardware and assets that are in the field. So I talked a little bit about the device security. Now on the other end, kind of what we're invoking in your account context, and how do we protect those? So in the same way that we're used to with AWS resources in general, you basically start with a bunch of policies. So the policies restrict access to different parts of your account. Like I can have a policy that says you can invoke this Lambda function. Another one can read from my Dynamo table. And something else can hit my Amazon machine learning endpoint. I take all these policies and I bundle them in something called a role. So then what you do from there is you take that role and you create what's called a trust relationship between us, AWS IoT, and that role in your account. So what you're saying there is that based on your policies in your account, you're going to allow AWS IoT to invoke this set of privileges. So in this way, you're completely in control of what we're allowed to invoke on your behalf in the rules engine. So this is kind of a thing I think that gets breezed over quite a bit. But this is a super granular policy. It starts with basically no privilege. So you allow anything you want that rules engine to do in your own account. And we do invoke it as you too. So nothing's passing through some magic black box on our end that we pass back to you afterwards. So the third piece, kind of the main piece and why we're all building these connected systems is that end customer. So we can connect and secure resources, users in the field in a little bit different way. And some of these are new since the launch as well. There was always the ability to use IAM roles and policies for user-based accounts. That's something that I think we all understand using AWS for quite a while. I can just create new accounts for all my users. Not totally practical for the types of systems that most of us are actually building. So with the release of WebSockets, we did a bunch of work around how would a customer use WebSockets in the field. So if you look at the machine-based systems that we're normally seeing, the machines can talk over these types of protocols. They can talk with certificate authentication. Not so great for users. So we introduced some features around Cognito. Cognito is one of our authentication identity services. So I can do something like create an identity pool with Cognito. I can allow anonymous access to a set of topics, maybe read-only access to a set of topics that's safe for the application level to subscribe to. Now on top of that, I can add my own authentication scheme now. So I can add my own username password box. I can OAuth to whatever I'm OAuthing to on my side, or I can have no authentication whatsoever. But now that web application can listen, read, and react to the sensor messages that I'm cleansing and publishing out to the application stack. So it's a much more user-focused approach to surfacing data in context of the application, and also completely protects you from opening up unwanted access back to the device itself. So this is a pretty cool policy in general. Actually, the last time I was speaking at a conference was about a month ago, and I did this demo where I had an iPad app on stage that was logged in using a cert in our iOS SDK. And I was drawing on the screen, and everyone in the audience had a web browser open and anonymously could subscribe basically to that same line, so you could see the pattern being drawn out in real time. And it also gives you that kind of one-to-n sort of publish-subscribe pattern, which is pretty cool. We're going to blog that example coming up in the next couple weeks as well. So device SDKs. I wanted to mention a couple new things around the device SDKs, and then we can kind of sum it up, and I'm happy to take some questions too. So again, one of the things we're really working hard to concentrate on is keeping all these things open and based on standards that have been adopted by the industry. So there's a lot of work around the Eclipse Paho project. We're actually starting to submit code back to them now on some of the changes that we've made for security models and provisioning of devices. So you'll start to see more of an active role in these types of environments. We launched with a CSDK. We did a reference build for Arduino just because it's cool. We launched with an iOS SDK, supports both WebSockets and MQTT. It is Swift, so if you're into Swift, it's a great way to kind of start building iOS apps. We'll start to see these additions to these into the AWS Mobile Hub, so you'll be able to spin up starter companion apps for your devices through the console as well. We released an Android SDK, and we just added WebSocket support for that as well. So if you don't want to send MQTT, you want a WebSocket instead, or your environment needs you to go over port 443 or something like that, that's a good SDK there. We added Node, but one of the things we didn't think of when we had the WebSocket support come out was that this could just be used in a static web app, right? So we just launched JavaScript SDK. I think that's getting posted to GitHub today. And you can use this in a static hosted website. So now I can take one JavaScript file, an HTML file. I can use a Cognito open authentication channel and basically get a WebSocket back to AWS IoT and just put my 2 files in an S3 bucket and host it from there. So you don't even need a web application to start visualizing some of the sensor data. So we thought that would be a useful SDK for people to kind of get started quickly. We could see these things ending up in like little portal frameworks or tiny visualization utilities, things like that. So that'll be up on GitHub with full instructions and a tutorial as well. So just to kind of go through what we talked about, and then I can take questions. So I just went through AWS IoT, some of the changes, the new region launch. Like I said, this is a huge focus for us. And one of the things to work with your customer partners as well. If you do have requirements in a region that we're not yet present in, please let us know. We like to hear these requests so that we can prioritize based on customer needs. Talked about the rules engine features that we launched this week. Again, this is the same sort of pattern. Please be vocal about, hey, I'd really like the rules engine to do this, or I'm jumping through hoops, with 5 different Lambda functions to get this basic task done. We would love to figure out how we can better help there. And bring your own certificate, one of the more enterprise-focused features that we released as well. So, like I said, we're going to have basically a deep dive around some of the analytics and rules features, especially the prediction endpoint. That'll be in the same room after the keynote. So if you can, we'd love to have you join there. So yeah, thanks for having me. I'm happy to take questions. You guys want to do it from the center mic? It's almost 7:30 Pacific time, so I understand if nobody has questions. So. Cool. All right. Well, I'll be up here on the stage, so if you guys want to talk offline, feel free to come up. All right. Thanks.